All right, so here we have section 2.1-1 notes. So this is the first half of 2.1's notes. And I put at the top here the title, Relations and Functions. So I've already filled in some of the words here, so we can just talk about it really quickly and not spend too much time on the video writing. So we're looking at relations first. Okay, relations are a set of ordered pairs. And that's all they are. They're just a list of ordered pairs. They can be shown in a table by mapping, a graph, or expressed as an equation. Okay, so there are there's actually 5 different ways to show them. We can also list the set of ordered pairs like in set notation. That would be the other way to represent them. Okay. The x values, the set of all x values is called the domain, and the set of all y values is called the range. So this should be a review for you. You should have heard these terms in Algebra 1. And a relation with distinct points is called discrete, and a relation with connected lines or curves is called continuous. So like a discrete relation would be something like a scatter plot. And continuous relation would be something like a graph, like that. Like a smooth line. Okay, if we look at functions, functions are just a special type of relation. In order to be considered a function, each element of the domain is paired with exactly one element of the range. Okay, so the way that I remember this is I write each x has only one y. Okay, so for every x there's only one y. We can't have for x equals 2, y equals 3, and y equals 7, right? It's just one pair. Okay, so an example of a function like in graph, listed as a set, if we, since this is set notation, we're going to be using the curly brackets here, and I'm just going to list out the set of ordered pairs. So if I had something like 0, 1 as an ordered pair, -5 and 2, 6 and -2, and 5 and 7. Okay, so this is a function because for every x value, there's only one y value. So if we have 0 here, there's no other, it's paired with a value of 1, and there's no other coordinate pair here that has a value of 0 with a different y. Okay, if we were looking at not a function, just a general relation, we could have something like -7 and 2, 6 and -1, 6 and 2, and -3 and 9. Okay, so here, because we have an x value of 6 that's attached to this -1, and we have another x value of 6 that is not attached to -1, it has a different y value, that is why this is not a function, because it has the same x value paired with different y values. Okay, so if we're listing as a set, that's how you can tell. If we are looking at the graph of a relation and we want to determine if it's a function or not, what we do is called the vertical line test. Okay, and that says in order to be a function, a vertical line cannot pass through more than one point in the relation. Okay, so for example, if I draw just like a linear function here, something like this, okay, and we were to do the vertical line test, I would see if I could draw a line. So this only intersects once, this only intersects once, this only intersects once, like the arrow doesn't count. So I'm only crossing the graph at one point each time, and it does have to be a perfectly vertical line. So this would be considered a function because it passes the vertical line test. If I were to draw something like a circle on the graph, this is not a function because we can easily see here that if we draw a vertical line, it will cross the graph in 2 different spots here. So I don't even have to try out any other vertical lines. I know automatically that's not a function. All right, so we're going to get into some practice of finding the domain and range here. So it wants us to find the domain and range of each relation and then determine if it's a function or not. Okay, so let's take a look at number 1. So we set that the domain is the set of all the x values. So what we're just going to do is we're going to look for all the x values here, and we're just going to write them as a set. So as a set, we open with, that was really bad, we open with the curvy bracket here, and generally we list these from least to greatest. So I'm going to start with -1, 0, 4, and 6. Those are all my x values here. And with the range, same thing. We're going to be looking at all of the y values, starting with the most, with the smallest. We have -9, -5, -2, and then 3. Okay, and then it's asking us, is this a function? So what we need to do is we need to look at the x values here. First, the first thing to determine, is there a duplicate x value? And here there's not. So we're not going to find another x value that is paired with a different y value because there's no duplicates here. So we'll say yes, this is a function. Looking at number 2, very similar here. So all of the x values here, we have 5, -3, 5, and 8. Let's start with the smallest, -3. And then 5 is listed twice, but when we write out the domain, we only need to write it once because it's included there, 5, and then 8. So even though there are 4 ordered pairs here, we only have 3 members of the domain because one's a duplicate. Okay, and then we have 2, 4, -6, and 0 for our range. So let's do -6, 0, 2, and 4. All right, is this a function or not? So let's look to see if there are any duplicate x values, and there's a 5 here and a 5 here. Now, if this were the same pair, if they were matched to the same y value, it would be fine because it's the same, but these are paired with 2 separate y values, and remember, to be a function, each x has only one y. That is the determining factor of whether it's a function or not. So we're going to say that no, this relation is not a function. All right, so same thing here, but we're looking instead at a table of values, which is a little bit easier to see. Our x's are listed here and our y's are listed here, so we just need to list those in set notation. So for the domain, all of the x values starting at the smallest, we have -4, then 0, 2, and 7. And then for the range, we have -8, -1, and then there are 2, 3 values, so we just need to write it once. And is this a function? So first we're looking, are there even any duplicate x's in here? And there's not. They're all different x's, so we couldn't possibly have more than one y value. So yes, this is a function. Number 4, another table of values here. For the domain, we'll start with the smallest, which is 10, then 15, then 18, then 24. With the range here, we have 0, 3, 7, and 11. We do not have any duplicate x values, so we know that this is a function just right off the bat from that. Okay, so looking at number 5 and 6, it looks like we're going to be looking at some mapping. So this is what we consider mapping when we have these 2 ovals and we have values contained and then there are arrows drawn to show the relationships here. Okay, so all of our x values are in the left oval here with the label of x, so we can just list those out from smallest to largest. We have -4, -2, and 5. Okay, and in the range we have 0, 3, 7, and 9. Okay, and is this a function? So we're looking for an x value that has more than one y value, and you can see right here this 5 is being paired with 7 and it's also being paired with 9. So that means that no, this is not a function because there's more than one y value to a single x value. All right, looking at number 6 over here. Same thing, listing out the domain here. We have 2, 8, 13, and 17. close that. The range, we have -4, 0, and 7. Is this a function? Well, we don't have any duplicate x values, so yes, it's a function. But I also want to point out that even though this y value is being paired with two x values, it can go that way. There can be multiple x values to a single y value, but what we're concerned about is multiple y values to a single x value. So just one y for every x. But if there's a y that's paired with more than one x, that's fine. But we have to look at it from the x point first. Number 7, we have a relation here. This is a discrete relation. You can see these are separate points. Okay, and we just need to look at the x values first for the domain. So starting with the smallest, that will be over here. So we have an x value of -3, two x values of -3. So we'll write -3. We have an x value of 0 here, of 2, and of 4. Okay, and then if we look at the range, we're going to look at the y values here. So we have, from the smallest one, we have a -5, we have a -2, a -1, a +1, and a +4. So -5, -2, -1, 1, and 4. Okay, is this a function or not? Well, we can see from our graph here that for the one x value of x is equal to -3 here, we have a y that's equal to -2 and a y that's equal to +1. So this would tell us that no, this is not a function here. We can also use the vertical line test here. We can draw a vertical line here at x is equal to -3 and see that we go through 2 points, which means that this is not a function. Okay, let's look at number 8. The domain here. So this arrow indicates that's going to the left forever, and this arrow indicates that's going to the right forever. Okay, so we'll actually say that this is all real numbers, or we can just write the real number set here. And for the range, these arrows indicate it's going up forever and down forever as well, so the range is also all real numbers. And we can do our vertical line test here. There's no vertical line we can draw that will cross more than one time, so we'll say that yes, this is a function. Number 9. The domain here, let's see, it looks like it stops here at this -4, but it does continue on in the right forever. So the way that we can write this, so we can't write this in set notation anymore because it's impossible to list out all of the x values, but we can show the x values as an inequality. And here it shows that the x, we don't have any x values that are less than -4. So all of our x values are greater than or equal to -4, and we'll just write that as an inequality. X is greater than or equal to -4. Okay, so there's the domain there. And then if we look at the range, this arrow indicates that we're going down forever, and this one says we're going up forever, so the range is going to be all real numbers here. And then the function, can we draw a vertical line that will pass through more than one point? And it looks like if I draw a vertical line here, I cross the graph here, and then I cross it again here. So that means that this is not a function because it did not pass the vertical line test. Okay, number 10, the domain here, it looks like if we're just looking on the x-axis, our x's don't go less than -2 and don't get bigger than 5. So x is greater than -2 but less than -5, and we know how to write this from our compound inequalities. So we can write -2 is less than or equal to x, which is less than or equal to 5. And then our range, if we're just looking at the y-axis here, it looks like we don't get smaller than -2 and we don't get bigger than 4. So it'll be very similar here. -2 is less than or equal to y. We're going to use y now because we're talking about the y values, which is less than or equal to +4. And is this a function? We already used this as an example, but I can draw a vertical line here and cross in more than one point. It fails the vertical line test, so it is not a function. All right, and now we're looking at an equation. So what we can do here for our x values is see, are there any restrictions on the x or y values? Are there any values that x cannot be? And the answer to that is here, no. There are no restrictions on the x value. We can take any number and square it and multiply it by -1 and add 3, and it will be just fine. So our domain here is going to be all real numbers. And our range, let's see, we might have to start using our graphing calculator to see what this looks like. So if I put this in the calculator, -x squared plus 3, and graph it, it looks like this. Okay, so we can see that our domain goes from, it covers everything on this x-axis going both ways. Okay, but our range, it only comes up to, what is this value here? It looks like it only comes up to 3. But it does go down forever, so it doesn't ever get bigger than 3. So our range here is going to be y is less than or equal to 3. And if we do the vertical line test, you'll see that it will pass. So we'll say that yes, this is a function. And number 12 here, same thing. Let's graph this on the calculator. -5x minus 1. This is a linear line, and it looks like this. Oh, it goes through. Does it go through the origin? It does not. It goes right under. It looks like this. Okay, so you can see here that our arrows extend up and to the left forever and down and to the right forever. So we cover all x values, and we also cover all y values, and it passes the vertical line test. So yes, this is the function. For 13, y is equal to -7. So this one you won't be able to graph on your calculator. But if you just mark out -7, if y is equal to -7, this is going to be a vertical line going like this. Okay, so the domain here will be all real numbers, and the range is going to just be one number, y is equal to -7. Okay, so there are no values of x that, oh, I did this backwards. Okay, that's why it's not making any sense. This is not a vertical line, this is a horizontal line at -7. Okay, that's why the domain is all real numbers, and there's only one y value, is only at -7. This passes the vertical line test, so yes, this is a function here. And then this is one that we won't be able to. So number 13 you can graph in your calculator, number 14 you can't. This is the vertical line at -1. Okay, so the domain is only going to be one value. It can only ever be equal to -1, and the range will be all real numbers. And this is not a function because you can see if we draw a vertical line exactly where this function it hits every single point. So it definitely hits more than once. So this is not a function. All right, and that concludes your